All right, so in our last example, we looked at interpreting the slope of a linear function formula in an applied setting, in an applied context. In this example, we're going to step back a little bit and just consider the general interpretation of the slope when we're given a linear function, but we're not given the context in which the linear function is going to be applied. So we're just given a formula for a linear function, but we're not told how that linear function is being used in practice. We're not told what the input quantity is measuring. We're not told what the output quantity is measuring. So we're just going to be giving here a very general interpretation of the slope of the linear function. So let's start with example A. So this is very clearly a linear function formula. It fits the format for a linear function formula. Remember, linear function formulas fit this format, where the coefficient of the input variable, which we usually denote by m, is going to be the slope of the linear function, and the constant in the formula, which is usually denoted by b, that represents the y-intercept of the linear function. So that's where the graph of the line will cross the y-axis. So if we look at this function formula, that is indeed a linear function formula. The terms are written in the opposite order. Rather than mx plus b, we have the y-intercept written first, and then the a term that contains the input variable is written second, but this is still a linear function formula. So it's very easy here to identify the slope of this linear function, because that's just going to be the coefficient of the input variable. So the slope of this linear function is -3. And again, that's usually denoted by the letter m. All right, so it's easy enough to determine what the slope is from the formula. But what's of interest to us here is what's the interpretation of that number -3. So what is that number -3 telling us about this linear function? Well, in general, what the slope tells us is the amount that the output value in the function is changing as the input increases by 1 unit. So let's write down that interpretation. Because the slope here is -3, we know that the output, which we're labeling y in this example, is changing by -3 units, or in other words, is decreasing by 3. As the input increases by 1 unit. So as the input x increases by 1 unit. So that's a very general interpretation of the slope. Because again, we don't know what the output quantity y is measuring. We don't know what the input quantity x is measuring. So our interpretation here seems to be rather abstract, but that's the best we can do in this example. Again, since we don't know how this function formula is going to be applied in practice. All right, so now let's look at example B. This is also a linear function formula. You just have a coefficient times the input variable plus a constant. Clearly the slope here is going to be 2/3. That's the coefficient of the input variable in the formula, and the y-intercept here is +4. Oh, I forgot to mention in this previous example in A, the y-intercept, the b value, happened to be 5. And we also have interpretations. Y-intercept also gives us a lot of practical knowledge about the linear function. It tells us where the graph of the linear function crosses the y-axis, and it also has important practical interpretations, but that's not of concern to us in this particular problem. But I did want to point out that the y-intercept here in example A is 5. So in this example, B, the slope, that's the coefficient of the input variable in the formula, so that's 2/3. Just since we noted it here, the y-intercept is 4. But what we want to write down is the interpretation of the slope. So now that we have the interpretation from example A, we can just sort of copy that. So the output y is changing by 2/3 units, or since this is a positive slope, that means that the output y is increasing by 2/3 units, again, as the input x increases by 1 unit. Notice that in our general interpretation of the slope, the input is always increasing by 1 unit, but the slope tells us how the output value is changing, and that might be increasing and that might be decreasing, and of course the slope value itself tells us the amount that the output value is increasing or decreasing by.